Welcome back to our Chem 152 video series. In this problem, we'll go over how to change between different concentration units. We'll begin with a 68 mass percent HNO3 aqueous solution. The first part of this problem will have us finding the mole fraction of both HNO3 and water in that solution. Let's start by defining mole fraction. Mole fraction is represented with the letter X, and underneath the letter X, we'll place the substance that we'll find the mole fraction of. We'll start by dealing with HNO3. The equation for mole fraction is the moles of HNO3 divided by the total moles. Now, in this solution, we have HNO3 and water, so we'll write moles of HNO3 plus moles of water. Our task here will be to first find the moles of HNO3, we'll mark that with an A, and then after that find the moles of water, which we'll mark with a B. To get those moles, we'll begin with the other piece of information we've been given, that the solution is 68% by mass. Let's think about mass percent also. When we are dealing with mass percent, we will assume that we have 100 grams of solution. Keeping in mind that percent really just means per 100. We are also given that 68%, that is 68 grams of that, will be HNO3. To find the water, we just need to subtract. 100 minus 68 gives 32 grams of water. We can use our grams of HNO3 in conjunction with our grams of water to get the moles of both HNO3 and water. We'll mark the grams of HNO3 with the letter A and the grams of water with B, because those are the quantities we'll be using for each part of the problem. For part A, we'll begin with 68 grams of HNO3. We will multiply by a fraction that takes us out of grams and into moles. So we're going to need the molar mass for HNO3. We have one H, one N, and three O's. Look at your periodic table and try to find the masses of H, N, and O. The mass we'll use for H is 1.01. The mass we'll use for N is 14.01, and the mass we'll use for O is 16.00. We'll multiply straight across, getting 1.01, 14.01, and 48.00. Now we'll add all of the numbers together and get 63.02. This number, 63.02, we place next to our mass, and place 1 next to our moles. Then, using a calculator, you can divide these numbers. We'll get 1.08 moles of HNO3. Next, we'll do the same for water. We have 32 grams of water. We'll multiply it by a fraction to get moles on top, grams on the bottom. We can also find the molar mass of water. We have 2 H's and 1 oxygen. We'll say 2 times 1.01, and then 16 for oxygen gives us a total of 18.02. Place that number next to grams, and a 1 next to moles, and once again, divide using a calculator. We'll get 1.776 moles of water. With these amounts of moles, we can find our mole fraction of HNO3. We'll take our answer from part A on the top, 1.08, place it again on the bottom, then we'll add our answer from part B, 1.776. If you're using a calculator, it may also help to place parentheses around the denominator to remind ourselves that we are going to add before we divide. Place the operation in a calculator. We get 0.378. This will be our mole fraction for HNO3. Now, to find the mole fraction of water, all we need to do is take 1 minus our mole fraction for HNO3. Since there are only two components in the solution, whatever is not HNO3 must be water. We can enter 1 minus 0.378 in our calculator. We get 0.622 for our answer. And so now we have the mole fraction of both HNO3 and the mole fraction of water. The next part of this question will be to find the molarity of the solution. We can use a bit of the information that we used previously for the first question to help us find molarity. But let's begin by defining molarity. Molarity, capital M, is moles of solute divided by the liters of solution. Let's remind ourselves that in the first line of the question, we've been given an HNO3 solution, and we consider that to be the solute here. Now, in the previous question, we already found our moles of HNO3, and so that means we already know what goes on top. We'll place a check mark there and show that it's the 1.08 that goes in that position. However, what we don't know is the liters of solution. We do have some information regarding the solution, in that we have 100 grams of it. We'll need to try to convert to liters. However, we can't go straight from grams to liters. Our density in the second line of the question gives the units grams and milliliters, meaning we cannot go straight to liters, but we must go to milliliters first. After finding milliliters, we can go to liters, and so this is a two-step conversion. Now, you may be tempted to start doing this conversion by writing down the density first, but I recommend against that. Instead, start by writing 100 grams of solution first. We'll multiply by a fraction to get us out of grams and into milliliters. The density here at the top told us that we have 1.42 grams for every 1 milliliter. Therefore, 1.42 goes next to grams on the bottom, 1 milliliter goes on top. Then multiply by another fraction to get us out of milliliters and into liters. According to our SI conversions, 1 liter is the same as 1,000 milliliters. Then we divide 100 divided by 1.42 divided by 1,000. And we'll have 0.0704 liters of solution when we place this in a calculator. These liters of solution now go into the bottom position of this molarity fraction. And now we'll write that molarity is our moles of solute over liters of solution. Our moles of solute are 1.08 moles divided by 0.0704 liters. We divide this in a calculator. This gives us 15.3 molarity. Now that we have the molarity, we can also get the molality. The molality of the solution is defined as lowercase m equals moles of solute divided by the kilograms of solvent. Once again, we know the moles of solute already. Those are the moles of HNO3. Place that in the top position and check that off. Now we need the kilograms of solvent. Let's remind ourselves that the solvent was the water. We don't know the kilograms, but we do have some information about water. We have the grams instead, and so we'll need to convert this to the proper units before we place it in the fraction. Thankfully, this is just a one-step conversion, because grams to kilograms is purely SI units. We'll begin once again with our 32 grams of water. We'll multiply by a fraction to get us out of grams, get into kilograms. 1 kilogram is the same as 1,000 grams, and so when we divide, we'll get 0.032 kilograms. This number will go in the bottom part of this fraction. Now we'll write molality is our moles of solute over kilograms of solvent. The moles of our solute was 1.08. The kilograms of our solvent was 0.032. Then we divide using a calculator. And we'll get 33.8 molality. This will be the molality of HNO3. So now we've gone through how to get mole fraction, how to get molarity, and how to get molality based only on the mass percent. Thank you for watching. We'll see you again soon.